Hey everybody. So today we are moving along in our notes on transformations. Yesterday, if you remember, we were looking at translations. Today we're going to be looking at what are called reflections. Okay, and we will eventually get to rotations, and then there's actually another one called dilations. All right, but today is all about reflections. The first thing I want to point out is attached. I've added this PDF. If you'd like to print this out and do your notes on this piece of paper, that is what I recommend. If you don't have a printer, that's okay. You can still follow along and basically just copy these simple graphs. All right. The title of your notes is this, the 2.2 reflections notes. So if you're writing this on a separate sheet of paper, make sure you get that as the title on the top of your paper. Okay, so let's just go ahead and jump in here. All right. Again, today is all about what are called reflections, and you have probably a good idea of what a reflection is. But let me show you how we do it in the context of transformations. Okay, so let's take a look at number one here. We're going to treat this like our example. So it's asking us to do a reflection across the x-axis. Okay, so here's our original shape. And again, they want us to reflect it over the x-axis. Here's what we're going to do on all of these problems. The first thing we're going to do is highlight the line we are reflecting over. Okay, this is telling us to reflect over the x-axis. All right, so let's go ahead and highlight the x-axis. That would be this thing right here. So on your paper, you can just kind of do like a solid line, or if you have colored pencils or whatever, just highlight it. Okay, so that is our reflection line, and now we can reflect our points over that line, and this is how simple it is. If a point is a certain amount of units on one side of the line, we are going to reflect it that many units on the other side of the line. Okay, so starting with M, we can see that M is 2 units below our reflection line, so we're going to reflect it 2 units above our reflection line. Actually, I'm going to make this blue. Okay, and there is where our new M would fall. Remember, our new M, we put this little symbol next to it, which stands for prime, to show that this is the image point, the new point. Okay, and we're going to do that with just all the points. So on N, looks like it is 3 units below our reflection line, so we're going to reflect it 3 above. Okay, there's N prime. Right, and then same idea with L. It looks like it is 5 units below our reflection line, so we're going to reflect it 5 units above, and there is L prime. Okay, just like when we were doing translations, after you get your points moved, we can connect the dots. Okay, on reflections, we should still see the same shape, but it should be a mirrored image of that shape across the reflection line, okay, which is kind of what you would expect. Okay, also another thing is once you get your new image here, also if you would highlight it a little bit, sometimes I forget to do this, but if you just kind of fill it in to make it really obvious, when we take our test, this will be especially helpful for me. Okay. All right, so I'm gonna have you guys go ahead and try one out. This one is also having you reflect across the x-axis. So the first thing is highlight that reflection line and go ahead and reflect your points over that line. Give it a try. All right, so let's just go ahead and see what you did here. It doesn't matter what point you start with, by the way. So I'm gonna start with L here. Looks like it's 2 units below. I'm gonna reflect it 2 units above. There's L prime. I'm going to go to M. Looks like it's 4 below. I'm going to reflect 4 above. K looks like it's 3 below. I'm going to reflect 3 above. K prime. And J, it's 5 below, so I'm going to reflect it 5 above. J prime. Okay, and again, after I connect these dots, should see a nice clean reflection over that x-axis. Okay, and yep, that's looking nice and mirrored. Also, let's highlight it. Let's fill it in. Okay, and this is kind of the basic idea of reflections. The only thing that's going to change throughout this lesson is the line that we're reflecting over. As long as we know where that line is, the reflection part is really simple. Understanding where the line is can get a little tricky, so that's going to be our focus. Okay, so let's keep moving. All right, so let's try these numbers 3 and 4 here. They're asking us to reflect across the y-axis. All right, so again, let's go ahead and highlight it. Okay, remember the y-axis is this vertical line right here. So go ahead and highlight it. Okay, now we can reflect our points across the line. Notice when it comes to the y-axis, our points, what we're looking for is, how far to one side is the point, we'll reflect it to the other side. So it's kind of like a left and right thing. So for example, I noticed that W is 1 unit to the right of our reflection point. So I'm going to reflect it 1 unit to the left, W prime. Okay, moving on to V, it looks like it's 3 units to the left. So I'm going to reflect it 3 units to the right. Okay, X, again, 1 unit to the right. I'm going to reflect 1 unit to the left, X prime. U is 1 unit to the left. I'm going to reflect 1 unit to the right. Okay, and don't be alarmed. Sometimes these shapes are going to cross over one another. Sometimes your points are going to be on, different sides of the line. It's all good. Just focus on what matters, and that's just reflecting each individual point. So after we connect our dots here, we should see a nice symmetrical reflection over the y-axis. And yeah, that's looking good. Let's go ahead and highlight it. Okay, so real quick, go ahead and try out number 4. All right, so we don't want to take too long on these ones because these are simple. We know where the x-axis is and the y-axis, but let's just look over number 4 real quick. M is 1 unit to, actually, let's not get too lazy. Let's highlight that reflection line. Okay, but yeah, M is 1 unit to the right, reflect 1 unit to the left. L is 3 to the left, reflect 3 to the right. K, 4 to the left, reflect 4 to the right. All right, so going through kind of quick, but I'm hoping this is starting to click with you guys. And there is our reflection, looks nice and symmetrical. We'll skip filling it in because let's keep moving. All right, so what happens when we get to problems that are asking us to, instead of reflecting over an axis, what if they're asking us to reflect over, say, the line of y equals -1? Okay, that's the hard part, right? Where is the line of y equals -1? Well, this is basically how simple it is. If you ever see a line or that is, y equals a number or x equals a number, that is a line that goes through that axis at that point. Okay, so this is telling me that it's going through the y-axis at -1. That's what my line looks like. Okay, so let's find that. Here's the y-axis. Here's -1 on the y-axis. So the line of y equals -1 is going through the y-axis at -1. Okay, that's our reflection line. Just to kind of point out, you might have thought that y equaled -1 was maybe this line. Okay, because the y-axis is vertical. Why isn't the line of y equals -1 vertical? That's just not the way it works. Okay, so don't get it mixed up. All right, the y-axis is vertical. The lines of y equals some number are going to be horizontal. Okay, just remember, through that axis at that point. Okay, through the y-axis at -1. Cool. Now that we've done that, we can reflect our points. So let's start with K here. Okay, remember, this is my focus. I don't care about any other lines here. Don't get it mixed up with the y or the x-axis or anything. All I care about is this line, and that K is 1 unit below my reflection line. So I'm going to reflect it 1 unit above. K prime. Okay, moving on to J, it is 3 units above my reflection line. I'm going to reflect it 3 units below. Okay, I looks like it's 4 units above the reflection line. I'm going to reflect it 4 units below. I prime. H falls on top of the reflection line, right? So it's going to reflect right back onto itself. So H prime is actually going to be right there. Okay, anytime a point lands on the reflection line, reflects right onto itself. Easy enough. Okay, so let's connect the dots. Let's just make sure this looks nice and symmetrical. Okay, and yeah, that's looking pretty good over that line. And let's take a second. Let's fill it in. Let's see, can I make this any bigger? Nah. All right, so yeah, there's the idea. So I'm gonna have you guys go ahead and try number 6 out. This one's asking you to reflect across the line of y equals +1. Okay, go ahead and draw that line, reflect your points. Okay, so the big question on this is, where is the line of y equals +1? Well, again, it is a line that goes through the y-axis at +1. All right, so hopefully when you went to start this problem, you drew your line. Here's the y-axis, here's +1. This is the line of y. Let me make it red. Okay, this is the line of y equals positive 1. Okay, that's the only hard part. Now we can reflect our points, right? So it doesn't matter where we start. I'm going to start with x, 1 below my reflection line, reflect 1 above. W, 1 above, reflect 1 below. V, 4 above, I'm going to reflect 4 below. U, 1 above, reflect 1 below. Okay. And at any point, if I go too fast, obviously pause the video. All right, so there it is. That does look like the nice symmetrical shape, same shape, just mirrored. Okay. All right, so let's go ahead and try some problems asking us to reflect over some different lines. All right. So taking a look at 7 and 8 here, they're asking us to reflect across the line of x equals a number. Okay, x equals -2 on this one, x equals -1 on the other. Okay, so let's find it. Okay, where is the line of x equals -2? Well, again, it's a line that goes through this axis at this number. Here's the x-axis. Here's -2 on the x-axis. So here is the line of x equals -2. Okay, again, it is not this line. Okay, this is actually the line of y equals -2 going through the y-axis at -2. It's really easy to get those mixed up. Okay, now that we have it, let's go ahead and reflect our points. S is 1 to the left, reflected 1 to the right. T is 3 to the right, reflect 3 to the left. R is 1 to the right, 1 to the left. U, 3 units to the right, reflect 3 units to the left. Okay. Connect the dots. And there we have it. Go ahead and fill it in. I'm going to skip that on mine though. Okay, so I'm going to have you guys go ahead and try out number 8 on your own. Go ahead and draw that reflection line of x equals -1. Reflect your points. Okay, so hopefully you're able to get this line. The line of x equals -1 goes through the x-axis at -1. So that is the line of x equals -1. All right, so let's reflect these points real quick. I'm going to start with y. It is 3 units to the left. I'm going to reflect the 3 units to the right. By the way, here's something I always see. People will say, oh, it's 3 to the left, and then they'll go to the y-axis and they'll reflect it 3 to the right, and their y point will end up here. Okay, be careful. It's easy to make that mistake. Okay, so there's y prime. Let's see, x is 4 units to the right. I'm going to reflect it 4 units to the left. Make sure your x and y images are in the same spot as mine. Okay, W is 4 to the left, reflected 4 to the right. Okay, and just like before, Z is falling on top of the reflection line, so it reflects right back onto itself. There's Z prime. Okay, so as always, should see a nice reflection. You know, the actual polygon, it should not look stretched or any, different shape. It should look like a perfect reflection. Okay, cool. So from here, they're going to ask us to reflect across the line of y equals x. Y equals x. Okay, before we had like y equal -2 or some number. Now they're telling us to reflect across y equals x. That's kind of weird, right? So let's figure out what that means. What is the line of y equals x? All right, here's a way of explaining it, and you don't need to write this. I just want you to watch this. Okay, one way of plotting or to plot the points of a line is to make a t-chart. Okay, if you guys remember, we can have all of our x values here, our y values there, and we can plug in our x values and get our y values. All right, so let's just pick some random x values. We can do that. So let's just say -2, -1, 0, 1, and 2. Those are kind of like go-to points when plugging numbers in. So what happens when we plug these numbers in for x? What do we get for y? Well, if we plug in a -2 for x, we get y equals -2. So if x is -2, y is -2. Okay, and you kind of get the idea here. If we plug in -1 for x, y equals -1. Plug in 0, we get 0. Okay, and so on. Okay, so here are the points of this line. Let's see what happens when we plot them. Okay, so this is a coordinate right here, -2, -2. That means we're going to the left 2, down 2. Okay, there's a point on our line. Okay, -1, down to the left 1, down 1, 0, 0, 1, 1, 2, 2. Okay, so you guys are starting to see this is the line of y equals x. Okay, you don't need to do this every time. This is just me showing you how we found the line. Okay, but now you just need to memorize, okay, y equals x. That's a line that basically goes from the bottom left corner to the top right corner. Make sure your line is hitting all of these little cross points. Okay. Okay, so now that we have that point, how do we reflect over this line? Okay, because this is kind of weird, you know, it's at a slant here like J. Where would J land? I think it would be somewhere over here, but I can't tell exactly where. Okay, well, this particular line has a rule to follow. Okay, and here it is. Okay, copy this on your paper here. What we're going to do is take our original coordinates x, y, and we're going to turn them into y, x. Okay, we're going to flip-flop the points. All right, so let's try it out here. The first thing we need to do is get the original points written out. Okay, so I'm going to put them here. You can put them wherever on your paper, but let's start with I. Okay, we need the coordinates of I. Okay, so remember when we find coordinates, we start in the center, we go on the x-axis and then the y-axis. So it looks like it's at +3 on the x, +4 on the y. So I, +3, +4. Okay, let's go to H. Looks like it's at -1 on the x, +1 on the y. So H, -1, +1. Okay. K looks like it's at -3 on the x, +3 on the y. And J looks like it's at -2 on the x, +5 on the y. -2, +5. Okay, so these are our original points, and here's what the rule says. It says that these points are basically just going to be flip-flopped. Okay, x is going to go on the right, y is going to go on the left. All right, and that will give us the coordinates of our reflection. Okay, so let's go ahead and do it for y here. Okay, I'm going to call it y prime. And let's see, actually real quick, let's see if I can make this look a little nicer. Never mind. Okay, I was going to change the colors, but we'll leave them the same. Okay, so I just need a flip-flop. So if I have 3, 4 for my original I, flip-flop the points, I'm going to get 4, 3. Okay, for H prime, -1, 1, flip-flop them, becomes 1, -1. Okay. K prime, -3, +3, flip-flop, +3, -3. And J prime, -2, 5, flip-flop them, becomes 5, -2. Okay, and these are the points of my reflection over the line of y equals x. Okay, so let's plot them, and again, we should see a nice symmetrical reflection here. So let's start with I prime. It's at 4, 3. So going to the origin here, going to +4 on the x, +3 on the y. There's I prime. I'm going to erase this. All right, H prime is at +1, -1, so to the right, 1, down 1. K prime is at +3, -3. And J prime is at +5, -2, to the right, 5, down 2. Okay, and let's connect these dots and see if this is looking good. Again, I'm going through this quick, so please pause the video if you need to. All right, and you guys can see we have a nice perfect symmetrical reflection over the line of y equals x here. All right, just to point something out, I could have maybe eyeballed some of these points. If I was here, I probably could have tell that I prime was going to be here. Same thing with H. I could maybe tell, you know, it's kind of like a slanted unit this way. It'd be a slanted unit that way. But with points that are really far away, like J, it would have been difficult to really land in the right spot. So using this rule right here is important. Okay, so I'm gonna have you guys go ahead and try number 10 out on your own. Go ahead and get those original points on your paper and then use this rule to flip-flop the points and get your reflection. Okay, try it out. Okay, so let's try it out real quick. Let's see, I think I'm gonna erase this. I'm gonna put it up here because I'm kind of running out of room here. Okay, so plotting our points here. Let's see, original, I'm gonna do this quick. E is at -3, -1. So I'm gonna make these ones black this time. Okay, so -3, -1. D is at -1, -1. F is at -2, -4. And C, +1, -5. Okay. Obviously, making sure those points are correct is really, really important. If you mess them up, you're going to mess up the reflection. Another thing we should get is, the reflection line. This is, again, reflecting over y equals x, this line. Okay, so let's use our rule. We're just going to flip-flop these points. So E prime becomes a -1, -3. D prime becomes, those flip-flop, they're the same numbers, so it's still going to be a -1, -1. Okay, F prime becomes a -4, -2. And C prime becomes a -5, +1. Okay, so really, these don't take that long, just the explanation kind of did. So let's plot them, let's see what happens. E prime is at -1, -3. Okay, D prime, -1, -1. Okay, which by the way, you can tell it's landing right on top of itself, which we should expect because it's on the reflection line. F prime is at -2, or sorry, -4, -2 to the right 4 down 2. And C prime -5 to the left 5 up 1. Okay, so kind of weird. It looks like they're scattered all around, but again, if you're using the rule, you don't really need to worry too much. After you connect your dots, you'll see a nice looking shape, nice and symmetrical reflected over that line there. Okay. All right, so yeah, those are kind of the weird one, guys. If you're feeling good on that, they don't get much weirder than that. All right, from here, there's just some problems I'm going to have you try on your own. The only difference on these problems is they're having you plot the original points and then reflect over a certain line. Okay, so on 11 and 12, go ahead and plot those originals. On 11, they want you to reflect over the x-axis. On number 12, they want you to reflect over the y-axis. Okay, go ahead and try those out. Okay, so I don't think I'm going to go over both of these, but I do want to do one of them. So let's take a look at number 12, okay, just to kind of finish things out. So plotting the original points, 1, -1. There's T. S is at 4, +3. And R 4, -2. Okay, so, first of all, oh, by the way, I should probably make these points black. Keep things, keep these colors the same. Okay, so there is my original, or if you guys remember, technically it's called the pre-image. I use the word original. Okay, now let's find our image. Let's reflect over the y-axis. Where's our y-axis? Right there. Okay, so that's the line we're reflecting over on this one, which by the way, on the last one, you were reflecting over this line, right? The x-axis. Okay, so let's see what happens. T is 1 to the right, reflect 1 to the left. T prime. R is 4 to the right, reflect 4 to the left. R prime. S, 4 to the right, 4 to the left. And reflections are really that quick once you get good at them. All right. So yeah, there is our second type of transformation, guys. I hope you're feeling good on this. I will see you back in class. Bye.